Now that you've had some time to play around with circuits a bit, let's look at what physics defines a circuit to be. In physics, we say a circuit is a closed path that contains both an energy source and a load. An energy source would be something that provides energy and would really transform energy from one form into electrical energy, providing energy for the electrons to move around the circuit. Our common examples of energy sources are batteries or transformers, which is what causes the energy when you plug something into a wall. A load is anything that takes that electrical energy and transforms it into another type. An example of that would be a light bulb, which takes electrical energy and transforms it into thermal energy or heat. And we know that when things get hot, they glow, and that's how we create light from a light bulb, at least a standard typical light bulb, not LEDs. Another example of a load is something called a resistor. A resistor is a device that simply has resistance. It also changes electrical energy into thermal energy, and it provides resistance when the energy that is given to us by our energy source is too much for some other object. So, for example, if we give too much energy to light bulbs, then they could burn out. So sometimes we need a resistor in our circuit to prevent bulbs from burning out. Now, another type of circuit that you may have seen in your investigation is something called a short circuit. That would be a closed path that has an energy source but no load, or maybe my load is too small. And when we have a short circuit, we get a potentially dangerous situation, because every time an electron travels through your energy source, it gains more and more energy, which means it starts moving faster and faster. And it's possible, if we have a short circuit, that you could cause a fire. That's often when you hear about electrical fires. It comes from this idea of a short circuit, where the load is not great enough, so it can't transform the electrical energy into another form of energy all the way. Now, there are two common types of circuits that we will study. They're called series circuits and parallel circuits. Looking at the difference between the two, if we have elements that are connected in series, then electrons are forced to travel through each of our loads. The two types of loads that we'll study in this course are resistors and light bulbs. So if we have a series circuit of light bulbs, then our electrons must travel through every single light bulb to complete a loop. Whereas in a parallel circuit, electrons would only travel through a single light bulb or a single resistor in completing a loop. So here's an example of a series circuit. Series circuits can look very different, but they will always have just one singular path, as you can see here. Whereas in a parallel circuit, this is just one example, so not every parallel circuit looks the exact same. But in this case, if we were to follow a single electron that passes through the battery, it would travel through only a single light bulb before coming back to the battery.